So today I'm going to show you how to calculate the determinant of a matrix. This may sound very easy for you, but when you have to compute this using a programming language, it might not be that easy, especially for beginners, okay? So there are many different methods to compute a determinant, but one big question is, what if you are given a matrix whose size is, say, 5 cross 5 or maybe 6 cross 6? That too will have a determinant, right? But you can't just follow the traditional method of finding out the determinant like you do while you're using your pen, isn't it? When you're using the pen and paper and finding out the determinant of a matrix whose size can be anything, say n cross n, you're not been given the actual size, then it becomes really difficult if the value of n is very large, isn't it? Suppose it's a 10 cross 10 matrix, then what will you do? You can't simply go on, excuse me, anyway. So you can't just go on calculating it in the normal way which all the mathematics books tell you, isn't it? So what we can do is there are few methods, and out of all of them, I think the upper triangular or the lower triangular method is one of the easiest. Okay. So we'll directly go to that. I have used Fortran language for computing it. Okay, so this is a program I have written in Fortran. I will be describing each step, but for that I have already done the what do we call that? Yeah, the dry run. I have already done the dry run for this, so I will be explaining each step. All right. There are few new keywords for those who are already acquainted with Fortran, or maybe they are masters in Fortran. Then they will know what this allocate is. Okay, this is a new keyword. Anyway, so this is just variable declaration in the first part, the purple ones, the purple variables. Okay. Now this what this allocatable variable does is it allocates a dynamic memory in the system. Okay. Like in general, when we have to assign the size of a matrix, or the matrix may not be always n cross n, okay, it can be m cross n as well, where the number of rows and columns do not match. But suppose if we want to use any random matrix size, we don't want to specify in this um, we don't want to specify in this bracket what the size of the matrix is going to be. So what we can do is we can use this allocatable variable, and this is how it is done. These colons specify that I have not exactly mentioned the size of the matrix A. Okay, so the size of the matrix is going to be basically n cross n here, because as we all know, the determinant of any matrix, if we have to find that, then the matrix firstly has to be a square matrix, isn't it? So this is how we allocate the size of the matrix, by using this allocate variable. It can be different for different programming languages. Okay. All right, then I have used this line enter the values in the matrix. I have simply done this so that we can enter the values in the terminal, and this portion, this whole do loop, is the actual calculation of the determinant. Okay, what each one does I will just tell you. You can just take a screenshot of this part, so that when I explain you the dry run, you will be able to understand what exactly I'm doing. Okay, or maybe I can just simply split the screen. Anyway, Okay, so I will directly go to this page. Okay, I have used Microsoft Whiteboard for calculating all of this. Let's just say that this is a matrix. I have not drawn it as a square. I'm sorry for that. It looks more like a rectangle, but it is actually a square matrix. Okay. So as we know, we generally represent the number of rows with I. This I can be small or capital. Please excuse me, I might have used capital and small in a mixed way. If so, then please forgive me. Okay. And J represents the number of columns. So there are 3 rows and 3 columns. So there are total 9 elements in this matrix. I have used this example because I found it relatively easy. All right. So I hope that you had already taken a screenshot of this part of this program. If so, then I can explain you the rest of it, starting from line number 12. Okay. So what our aim is that we have to convert this matrix in such a way that it finally becomes like an upper triangular matrix or a lower triangular matrix. Okay. And I hope you know that. If you don't know, then I will explain you. An upper triangular matrix is the one in which there are elements only above the main diagonal. The left diagonal is the main diagonal. So if there are elements only above the main diagonal, then it means below the main diagonal, the elements have to be made 0. Okay. Similarly, if I am talking about a lower triangle, it means elements have to be there below the main diagonal. So there will be zeros above this diagonal. Okay. So for a 3 cross 3 matrix, if I have to find the upper triangular matrix for this particular matrix or any matrix, the elements below this diagonal have to be made 0, and there are 3 elements. In this particular matrix, they are this 2, this 3, and this 4. Only these 3 elements have to be made 0. Okay. Now I just hope that you have already clicked a screenshot. I don't want to repeat anymore. Okay. So if the loop starts from I equal to 1 to n, that is I equal to 1 to 3, I equal to 1, I equal to 2, and I equal to 3. So for the first iteration of I, you will see there is a condition if j greater than I. If j greater than I is fulfilled by these two conditions, that is 2 greater than 1 and 3 greater than 1, because 1 is not greater than 1, right? So that condition is false, but these two are true. So for both of these conditions, I have found the ratio. If you check in my program, I had calculated A21 by A11. How this comes? It comes from this line. AJI divided by AII. So in my first case, AJI is A21 divided by AII is A11. And for the second case where 3 is greater than 1, AJI is A31 and A11 is the same, II. Okay. And we have calculated a particular value of this ratio. We are going to use this ratio for using it in the next nested loop, that is the K loop. You can go and check the program. You see there is a nested loop, nested K loop. Okay, we have used this ratio here. So we need this value of ratio. Now, this K loop will go up to 1 to n, that is again from 1 to 3. So when K is equal to 1 for both the cases, I have calculated the values of aj comma k. Okay, then again for k equals 2, I have found the value of a of j comma k, and finally again for k equal to 3, I have found the value of a j comma k. So this all of this is happening on under I equal to 1 only. Okay, I have not done the bigger second iteration yet. These are the nested loops going on still. Okay, so what is the new matrix that we get here? The new matrix, if you check, the first column already has got two zeros over here. All right, and I have marked this one element with a red circle, means I have not yet got the lower triangle, isn't it? So, and moreover, the loop will not stop until it has reached I equals 3. So, if I is equal to 2, I want all of you to solve this on your own, the way I have done everything for I equals 1. It's the same, but you just have to be a little bit careful with the calculations. And if you try to do I equals 3, you will see that all the conditions fail, meaning the condition which was j greater than I, this fails when I is equal to 3. Why? Because you see, I will tell you, 1 greater than 3, 2 greater than 3, and 3 greater than 3, all of these conditions are false, isn't it? So for I equals 3, this whole process will not be calculated, and you will find that you have already got this lower triangle. Rather, I should say, I'm sorry, I should say the upper triangle, because there are elements above the main diagonal. So we have made all the elements below the main diagonal 0. I have marked that with this triangle, okay? And now our job becomes very, very easy. Now, the trick is, after we have already got this upper or lower triangle, you can also try this program using a lower triangle perspective, okay? Anyway, so after we have got this upper triangle consisting of 1, 1, 1, minus 5, 2, and 12 by 5, what we will do is, you can see there are elements on the main diagonal. We will simply multiply them. That is, we'll do 1 into minus 5 into 12 by 5, and that gives us minus 12. You can simply check this value by directly doing it with your own hand like we normally do. That is 1 into minus 3 into 5 minus 4 into 4 minus 1 into 2 into 5 minus 4 into 3 plus 1 into 2 into 4 minus 3 into 3. So that thing also will give you minus 12, okay? So that's how this whole program is. And the good thing about this whole code is, or I should say this whole method, upper triangle or lower triangle, is this works for for any for any size of square matrix. It means if n is say 100, then also this same method will work, okay? I hope you found this video helpful. If you have any questions, you can just write them in the comment section. Thank you very much.